Hey everyone, it's Chashmi. Today I'm gonna show you how to implement the SHA-256 hash algorithm on Python. But before going to the code, let's just dive into the flowchart of the map, and then we are going to explain each part of the code, because I already put the code in the GitHub and the code alone is not very understandable. It's like this for all of us. So it's better to first go for the flowchart, and let's just make it a step-by-step approach to understand what's going on. First of all, what is SHA-256? SHA-256 is actually it stands for Secure Hash Algorithm, and it's for converting a message which always must be 512 bits in the input to a 256 output, bit output actually. So if I just make it more visual, it would be like you have a 512 bits message which goes into this. You could just look at it as a function system. I usually show it as a system to 256 bits output, which this is an hexadecimal format. You maybe saw it already many times, this format, because it's very famous algorithm. But we are going to explain here that how it's done and where it came from. First, the algorithm says that how to convert the message. Not always your message is 512 bits, so somehow you have to convert it to 512 bits. So we are doing it over here in these 3 steps. Then we are going to prepare our 512 bits. Later on, we are going to go for the compression loop, which is the core of the SHA-256 step. We are doing all of these steps until we come over here. Don't worry, don't make it so hard, don't make it so big. We are going to explain each step. I'm just making a big picture view of what's going on, so don't make it so scary. Otherwise you would be frustrated and leave the video. So we are going to find this compression loop. This part is actually the SHA-256 system. In here, this is what's going on to the message. So in here we're creating our 512 bits. Then this is our system, the 512 bits going into this system. Then here's the result and our hexadecimal output, which is 256 bits. And yeah, that's it. Very easy, right? And I'm already also going to put this flowchart in the link of the description. You can just download it anytime. Also, I did the code. You can just download the code as just open the GitHub repository I have and just use the codes, so you don't have to follow each step to type it by yourself. So we are going to explain what's going on. By the way, I'm going to code it step by step. I'm not going to just open the code and explain on it, because it would be a little bit hard to understand. So it's better to go it step by step. Alright. Let me just make it right here. So let's go by first step. What is first step? It's called conversion. Yeah, conversion to ASCII. Actually, I must say conversion to binary. Okay, much better. Okay. You fix it as well. If I just set the picture wrong, you fix it. Conversion to binary. Look, any message that we have, for example, we always just got used to the hello world. Let's just make that an example. Hello. Actually, this one is not. Hello world. Alright, this is our message, and we are going to send it to our system. Here, the computer, which is in here, does not understand our language. It's just English language. Maybe you speak Persian or someone speak Indian. It doesn't understand. So we have to convert it to the computer language. So we have to convert it to binary. How we can convert the message to binary? Look, we can just search in the internet and type it one by one, that what's the value of H, what's the value of E, what's the value of L. It would be just so frustrating. Don't do that. Instead, let's go to the Python and code the binary conversion. Alright, binary conversion. So, our message is what was that? Hello world. This is our message, and the binary value of this message is, we have to just use a format. It's just how it is done, how it's working in the Python. I don't know about the other languages, but you have to type this format to convert it. So, and it's an 8-bit, so it would be 8-bit conversion for character in the message. Right? I guess it's right. Even it's not right, the actual code is in here, so we can just move on and look what's going on. I'm sorry. So we're going to print the binary value. Alright. What's wrong in here? Binary value is 8-bit for character in message. 8-bit character order value. Alright, what's the problem here? Parentheses. Oh, sorry. I guess mistake over here. In order to, actually we don't need these parentheses. No, it's right. I missed the parentheses over here. Yeah, I missed the parentheses over here. I'm sorry. That's fine. Invalid syntax. Print binary. Yeah. Alright. This is the binary value. This binary value is, as you can see, it's 8-bit. We find it over here, 8-bit. Is the value of each one of these alphabets. H, E, L, L. This H, even the space over here has a value. It will be this one. And we just defined it. So now we are going to do something. Look, after defining the value, let me just join all of these values. Yeah, let's just join them. I just want to copy it. How will we do it? We're going to use the join. Okay, that's not that hard. I think the one. No, I did not want joining. Okay, binary string. It would be like this one. We're going to join it. The binary value. If we just print this one, it would be the joint binary string. Why are you just making it so hard for me? Yeah. Okay. This is the binary value. We just attached all of these values. Okay. We didn't do anything very big or special. We just attached them. So this is the value. What is happening? Okay. what was that? Okay, just copy this and make it this one, make it a little bigger, like 15. All right, that's the deal. How many bits it is? All right, I just counted it before. It's just not hard to count it. It's just 88 bits. So 88 bits is not very, I don't know if is it 88 bits. Yeah, I guess 448, maybe just no. Yeah, done. It's 88 bits. So these 88 bits, actually how I realized it's 88, I just thought about how many alphabet it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 11 times 8 bits would equal to 88. So yes, we are right, it's 88 bits. So here we are going to convert it to 512 bits. But how we can do it? Now we did this step, I'm going to just make it colorful like green. We did that. Now we are going to do the pre-processing. The pre-processing is very cool one. I like it. Look, this is the message. This is the length of the message. Which is 88 bits. We're gonna sum it with a binary number of 1. Like we would put a 1 over here. Task y. So now it's 89 bits. One more bit. Also, we are going to add zeros. Yeah, add many zeros until 64 bits away. It would mean like we are going to add 0, 0, 0, zeros until it's 64 bits away. Like we are going to make it, let me just type it to understand it much more visually. With hands, it's just not even professional, not very cool. So first of all, we are going to add the 1 bit, adding 1 bit. Okay, it would be binary string with definitely 1. Okay, it would be the same binary string that we defined plus 1 bit. So if you print it, it's the same but with 1 bit, right? Then just I don't have the power to type all of them. So I type it right? Yeah. Look, yeah, it's the same one with 1 bit. Okay, there's no huge deal. So we added the 1 bit. Now it's 89 bits. We are getting close to the 512 bits, right? We're supposed to reach to this point, 512 bits, because the input the system, the SHA system understands is 512 bits. So we are getting close. Next step we go on is our target value. Until we add the zeros, we are going to add many zeros until 64 bits away from the 512 bits. It would be like 512 bits minus 64 bits away. Yeah, 64 bits. That would be 448 bits. So our target value is 448. We have to keep that 64 bits. We are going to do the third step of the proper pre-processing. So first step of pre-processing was adding the 1. The second step is adding zeros. And the third step is adding the final 64-bit value, which I'm going to explain what is this 64-bit. Okay, now just keep this one. Okay, now keep this one. We are here. Alright, let's just go and add the zeros. So our target value, okay, this step is padding, let's say, to 448 bits. Our target value is 448 bits. Okay, current length is the length of the str, right? Here here we go. And we are going to add zeros to path. Zeros to add. Here we go. We have the target value. Length. I wrote target value. I just have to make it target value. Minus. Here's the current length. Okay. That's right. Yeah, that's right. Let's just print it. That's just how it is done. Zeros to add. I mean. Okay. It means that it has to add 359 zeros to our message. Our message was 88, actually 89, 51 bit added. So we are going to add another 359 zeros bit actually to make it 448. And after that we are going to add the 64 bits to make it 500. Okay, let's just make this comment. Let's just comment this because it's not cool. I just added to look what is it done. Okay, padded binary. That binary actually is string. Yeah. Sorry, I'm not. My main language is not English. Then binary is string. What was that? Yeah, with one, not binary string. We want this one to be added 359 zeros. We don't want this one. So binary with 1 plus zeros times the value, the amount of zeros. So we want 359 zeros, so we're gonna just not type it's 359. You know, the value of zeros to add is 359, so it would just create 359 zeros. I guess we are done. Yeah, we're done. Let's just print this one. We're done here. That's much better. Okay, we're going to print it. Padded binary string. Let's just do it. All right, that's done. That's perfectly done. So we did it. We are just gonna copy this. We're gonna copy this and paste it over here. This is the next step. Okay, we did the first step. Now we are here for the second step. Now we are going to add 64 bits. Where these 64 bits came from? Look, this 64 bit is the encoding process. For encoding the message, we have to add this 64 bit, and it's the representation of the message we have. So if it's 88 bits, it is just going to convert it to binary, okay? The binary value. And let's just convert it to binary value. All right, that would be like, we can't just do it with the hand, but let's just do it with Python, because our message session is with Python. So we already know that adding the last 64 bits. We already know that our original message is 88 bits. Yep. And the original length message length, I'm just making it so long. Okay. Our original message to binary, let's just make it. Yeah, binary. Okay, we are just going to convert that 88 bits to binary. Nothing special. Okay, format, just like we did in the first time. What was the message? Original, which is 88 bits. We can convert it to 64 bits, okay? Not 8-bit like the first time. Then yeah, that's it. Actually, no, not it. We have to just sum it to the previous message. So the final binary string is the padded binary string, plus the original length. So that is which is 64 bits. Now we have our 512 bits. Let's just check we did it right. Print final binary string. Yes, perfect. We also did add that 64 bits as well, so our message is done. Finished. Our input is ready. Look, we are in this here. We did the proper pre-processing, so the input is ready. Actually, we have to split it to 16 bits. Like, we have to split this binary to 16 32 bits binary codes, binary blocks, like 16. It can convert it to 16 32 bits if you just made it, combinations. It is possible. Then that would make it the first step is done. Then we are going to go for the constants. There are some values like preparing the message schedule and initializing the there are some default values, there are some default hash values that I'm going to explain where it came from. They came from the fractional part of the roots of the prime numbers. Yeah, it's just very heavy word. Don't worry, don't make it very scary in there. I'm going to explain how it is done. Don't worry at all. And we are going to create our core, our last step or main step to create our core. And we are going to do that. And at the end of the course, we are going to update our old hash values, which are some hash values, prime, I don't know, roots of the fractional part or anything. We're going to just update them by adding the new values to the old hash values, and that's our 256-bit output. And that's it. We have done it. And just check. Yeah. We have done it. Okay. Now let's go. Let's go for the other step. Now we are going to split it. Why we are going to split it to 16 message? That we would just ask in your mind, why are you out of your mind? Why you are going to do that? Let's just do it in this way. The problem is that we cannot do it in this way. In the message schedule, we have to convert it to 64 message, not 16. And the first 16 message is already the same value as this binary. And after this 16 message, we have to do some calculation. And there is a formula for this calculation. We are going to type it over here, and I have the formula. I didn't memorize it. I'm going to write it over here as well to calculate all the 64 message. So yeah, it's just some calculation, not such a big deal, and we are going to do that. So look, after I type it over here, I'm gonna just present it much better with the values, with the messages, and you could understand it. So don't be feared what's going on. Oh my god, we're gonna watch a 40-50 minutes course. So let's do it. We're gonna convert it to 60, converting to 60, no, not 60, 16 32 bits blocks. Alright, let's do it. Converting. So our blocks are supposed to be the final value. What was the final binary? Okay. We're going to convert this one, actually. That's definitely. To how many? To 62-bit blocks. For I in the range of 32 bits. Yeah, right. I'm sorry. Still, here we go, and for we're gonna just make it shown in our output message, like from 0 to 50. That's why I'm creating this for loop. You just define the index, then get the block in the enumerate. We have just defined it. Enumerate blocks. Okay, not a big deal. 80 seconds, and you'll understand what's happening. Then print the message. And I want it to be counted. That's why I'm doing this. Don't worry, you understand what's going on. To the what blocks? Okay, that's all. Block action. All right. Done. All right. Look, it's the same message over here, just converted into 16 messages, right? This is the first 16 part, 32, yeah. 32 parts, like here. The other 32 parts here, and just keep going until there are many zeros in here, and the last 32 bits. So we are going to the biggest step. Okay, let's just get this one green as well. We are going over here, preparing the message schedule, which is there are 64 messages. What's the formula? Before going on, let me just write the formula. Okay, message schedule. Message. Where's the here? Right. Message. Look, the first 32 bits, the first 16 bits it would be the first, like 0 to 15. The first ones are the same as messages in T, actually, not M. As the first as the message, we have like 16 messages. So for the 16 first ones, like M1, M0, from M1 to M16 are all the same as here. But for the other ones, which is there are 64, that would be 16 to 64 or 3, no, 63, I'm sorry. That would be this formula. Just keep in mind this formula, and we are going to just solve all the equations. All right, I'm gonna write this formula. Okay, I can't write it over here. It's just so big formula. So let's just write it over here. That would be this one. T equals to sigma 1, T minus 2, and plus W2, not W2, T minus 1, plus sigma 0, and WT minus 15, plus WT minus 16. Also, you know that these are the W0 to W16 because we just said they are equal to the first 16 ones. So I just wrote WT minus 17. It would be message number 8, right? This is this one. So the value is defined. So it's W minus 16. It would be this one. Actually, not 16 to be honest. I guess I'm making this. I don't know. So it would be the very first value. Yeah, that's right. There are 16 bits. Yeah, 16 bits. That would be W0. That's the first message. So this is the core formula we have, and we are going to use. And what are these sigmas? Okay, I define these ones. We define these two ones. And what is these sigmas? Look, these sigmas has a calculation. Look, Imagine we are taking this message, this WT minus 2, like it would be this message, right? 0, 0, 0, 0, 0. It's just so boring actually. Let's just pick up another one, like this one, message 2, okay? Let's just explain from here. What's happening with this code? I have no. Yeah. Getting into my nerves. Why I cannot copy? Okay, there is always a solution. Here never fails. Oh, it's much better. Okay, go away. Here is the message tree. Okay, I know it's written message 613, but I just want to explain how this sigma works. So how does this sigma works? Look, first we're gonna do the modulation. Modulation, no, like shift right. We're gonna just do 7-bit shift right, and just making in a loop, like 7 modulo the message. It would be like a loop. It means the message that we are shifting, it would come back from here. That it's not like shifting and we put zeros over here. It's just going and coming back. Like so, the value over here, like 0, it would be shifted 7 bits, like 1, 2, 3, 4, 5, 6, 7. It would come over here, as well as all the values over here would come over here as well. And you would wonder what would remain in here. We just shifted it and it's now in here. That would come from the values in here. It would just go back and come over here. So it's like a loop that we are shifting anything, and it is not ending over here. It is just teleport, and it just teleports over here. Okay, that's good. We do the same for 15. Am I right? No, not 15. Values, it would be doing the sigma 1. Sigma, I'm sorry, I'm just explaining this one, not this one. This one is another thing. I'm explaining sigma 0. I'm gonna explain about sigma 1 as well. Okay, this one is sigma 0. So we already explained. Okay, we're gonna just shift it this amount. Then for the other value, it's 18 bits. 18 bits loop. So the value over here would go 1, 2, 3, 4, 5. Okay, maybe 18 is over here, would come over here, then it would just go over here. Then we're gonna do the, after doing all of this, no, not actually after doing all of this, just it's not like a step by step. We first do it, then we do this, not then we do this one. We first do this one, okay, that's defined. Then we do this one, then another one defined. Then we are going to do the 3-bit shift. Shift 3 bits. That would be just shifting all of these values to 3 bits. Then that value in here would be in here. Then we're gonna put zeros in here. Okay. When shifting, then like sampling. If you are you have studied digital signal processing or DSP, you know, then we do sampling. When we have no values, we put zeros. So that's defined as well. Okay, that's it. Now we're gonna XOR all of these. All right, XOR all of these values. It's like a system goes into this, then there is one value, then there is one value. We're gonna do this XOR combination in the Python. Don't worry, just wait a second. I'm just being very worried about how long is getting this video. That's fine. All right, let's go. Let's not make it even longer than it is. So for the other value, I'm just going to copy this one over here for sigma. Okay, let's remove all of this. For the other value, we're going to do the same. This is for sigma 0, sigma 1 actually. Not doing the same, definitely we're going to do something different. Right. It would be 17 shift not shift, loop shift, then 19 loop shift, then we are going to have a 10 bits shift, then XOR all of this. All right, XOR all of this, then that's it. Okay, we defined the sigmas and we defined the messages, which now we just made it equal to W. That's fine, not a big deal, it's just a constant. Then we sum all of that, that's fine, they're just summing, not a very big deal. So let's just do it in the app. So first of all, we are going to do the messages. Yeah, it's big deal. Message. We are going to first define the first values being as. Actually, I'm before going to do the definition. No, that's fine. Let's just define it. Okay, define b to equal for the first values for b in blocks. Okay, we're just taking whatever value there is for the block and make it equal to our value. Not a big deal, we're just making an equal. So that's it. Then we are going to, this is for the first four, because it's a little big, I'm gonna make it more understandable by making more than one message, one comment. I'm gonna make different comments. This is for the first 16 messages, all right? Messages. Okay. Then we are going to define the right shift, right rotate. Actually, not a big deal. Right rotate is a little bit tricky. I did it and I realized I'm not getting any answer, so we have to rotate it. Define right rotate, which is xn. Then right rotate. Right. Return x, then when it's bigger it's going to n, then or with x being bigger than this one, 32 minus n. The value is, and we have to just make sure it's not surpassing the 32 bits, so we're gonna just making sure 3, 4, 6, 7, 7. I guess, yeah, 32 bits. 8. Yeah, it has to be 8. Yeah, it has to be 8. I'm sorry. It's 32. Okay. Then for the 48 messages remaining. Alright. We already defined the 16 first one. It was easy. Now we're going to go for the 48 messages remaining. And also this part is for the 48 messages. Oh, okay, this part a little bit tricky. Just follow me, okay? For I in the range of the 16 to 64. Okay, 16 to 64. We're gonna define the sigma 0. I'm defining the sigma 0. Okay, right rotate. What I'm doing right now is exactly what I explained 2 minutes later ago. Okay, I minus 15. Or also we could just 7 XOR with the, I just said XOR them, right? So we're gonna just define this. XOR them with the right. Okay, for not making it so long, because you already understood where this formula came from. So for not making it so long, I'm just going to find only this first one. Then I'm going to 18. I said 18. Then I'm going to copy the rest of the codes because I already have it in my GitHub. Yep. Then I minus 2 minus 15, minus 15, which is shifting it with the value of 3. Yeah, shift 3. That's fine, that's fine, that's fine. Perfectly done. Okay, let's just copy the other code. I don't have the energy to write all of it. Okay, I'll shift this one. For God's sake. And you have the new word, yeah. Definitely we're gonna just sum all of that. This new word is the summation. New word is like 16, that's fine. Is 0, 1, sigma 1 is sigma 2 is exactly this formula. This formula, not a big deal. Alright. Let's sum this one and we're gonna append them. Just make all of them attached. That's a big deal. Appending, like adding to the ending. We could just memorize it like this. Adding to the ending. Appending. Okay, let's append them. Append the new word. Okay. Now let's just print it, shall we? Index word in enumerate. Print f index. So let's just print. Okay. So here we go. Now we have our the first 15 to 0 or 16 message is already exactly the same. You can see it's exactly the same. There's no difference. If you look at it here, yeah, look, there's 0, 1, 1, exactly the same one. And for the first line is exactly the same one. That's cool. That's cool. That's cool. Now we did the difference over here from 16 to 64, and as a result, that would be 512 bits. All right, that would be 512 bits. Still, we are in the first part. We are still in the first part. Okay, we are just make it this green one. We are still in the 500 in the input. We need our value to be 256 bits because the output must be 256 bits. So we have to do some initialization. And before doing the initialization, let me just tell you about the default values of a hash function. Actually, for not hash function, for the SHA function. There are some values that I'm just keeping it over here. The SHA initial value. Let me just print it. I didn't memorize them. Either you should do it. And they came from the fractional part of the prime number, the roots of the prime numbers. Like for example, what are the prime numbers? 2, 3, 5, 7, 11, 13. So I will just take this one. The roots of the 2 would be 1 point. Okay, I don't know. 4, 4, 4, 4, 4, 4. Not 4. 4. Yes, 4. 4, 1. 2, 3, 5, 6, 2. Anyway, it's just so long. So we're gonna just take this fractional part and convert it to binary. Then converting that binary to hexadecimal. And when doing that, you're gonna get this first value. If you do it for 3, you're gonna get the second value. If you're gonna do it for 5, you're gonna get the third value. And when you keep doing it, you're gonna have your initial, the final value, hash values. But these hash values, if we XOR all of them, that would be like 256 and bit hash value. That's fine. We don't just do that. No, don't. If you just have no message, if it's empty, that's the value, right? But when you have a message, any message in the input of a SHA-256 value has the exact same output. So if you just put one space in your message that you put, that would make another whole hash value. Yeah, if we don't do anything, this is our hash value. We just have to merge all of them, like XOR all of them, and that's our 256-bit output. But we have to do something. We have to initialize it with the new value. we have a message which is hello world. This hello world has many values, and these hello world values have to be summed up with these values. Then we're gonna merge it and put it as our output, and that's our value. So for just making it easy, I just made them equal to A, like the H1, H2, H3, it would be like A, B, C, D, because that's the rule. Don't ask me. Okay, we are going to go down and making our core. This is okay. We did the initialization. Let's just make this one green. We are still in the system. System. We are doing the hashing computation. That's definitely, I just explained. We're gonna sum the new values of hash with the old values of hash, and that's our value. That's it. Done. We have our output. So we are over here. That's the big deal. Very big deal. We have to make it very clear about how this part works. Look, before going on, let me just write this formula. Look, hashing is very, very long course. It cannot be just taught in one session. And it got so long, 46 minutes. All right, that's very much. All right. Okay, this is the formula. The formula is written like this. Let me go down. It is written like H equals to G, G equals to F. Yeah, the same values. You would be why did that H equals to G? Don't worry. Just cover me. Just follow me. Cover me. It's not battlefield. What are we saying? Okay. F equals to E, and E equals D plus this one T1. Okay, let's go. D equals to C, C equals to E, and B equals to A. Also, A equals to T1 plus T2. So these T are also called temporary 1, temporary 2. These T1s made all the difference, right? These T1s made all the difference. We have to define this T. And for defining this T, we have a value. The T1 is equals to H, this one, plus sigma 1 of E plus change of E, F, G. Understand? It's just getting a little bit tricky. We have to just change the positions. Plus K, which is a constant, then plus W, which we define these constants. This K and W, they're just different constants that we defined already. So we define the K, we define the omega, W. Then that's it, I guess. Let me just close it a little bit. So yeah, the omega, K, the constants, the choose, and the T2 is also, let me just close this one, it's just making me bothered. T2 is also defined as sigma 0 A plus majority ABC. Look, and these values over here are from the initial values. Don't mistake them with these values. So we're gonna just find the initial values and put them over here and pick them. How we pick them? Okay, you would say what is CH and what is majority, and also what is sigma. We already defined one sigma up there. What's the difference between this sigma and that sigma? Okay, let me just explain. This H is also already visible. You know what is H? Just we initialize the values over here. So the H is this one, right? This is the H. That's a big deal. Then we are coming over here, the sigma. What is the sigma? Okay, just like the first sigma, this sigma has a method to work on. So for sigma 1, I'm rating it right. Yeah, I'm doing it very well. Okay. For sigma 1, it would be like this. First we do the two modulation, two for loop, not for loop, like a right rotation. Then we're going to do this 13 right rotation. Then we are going to do the 22 right rotation. Then guess what? Yeah, XOR all of them. How about this sigma? Okay, for this sigma, it's just like this one, but with different values. We're going to do the 6 right rotation. Then do the 11 right rotation and 25 right rotation. Then yeah, as well as that one, we're going to XOR all of them. So for the sigmas, we already just explained what are them. We're going to just do some of these right rotations, and that's all. So what's these ones? This may choose, or CH already called, or majority. Before going for that, let me just tell you what are these K and omega. Okay, we already calculated the message schedule, which is W. And what is K? K is another constant which is defined in the SHA-256 categories. Like I have it over here, like constants, K values, and for each bit, for bit 0, it would, for this value it has this value, for bit 1 it has this value until 32. Okay, for 32 bits. So we just gonna pick whenever in any values values we are. So that's not a big deal. I'm just gonna copy this. I'm more lazy to type all of these. Okay, these are the constant values. Then we have this one, choose a majority. Okay, we explained this one as well. Now let's explain what is choose and what is match. Alright, I was just missing. So let me just copy some values. I don't have the English to type all of it. Choose A, B3. Okay. Before here. So let's just pick up a little bit value. I just want to explain how it is done. I don't want to, and this answer is not the final answer. Python does the final equation. I just want to explain how. Okay, look, when we have choose equation, we look at this value, this first line values. If it's 0, actually I didn't have to pick up this one. I don't need this one. I'm just picking between two values. Alright. Yeah. So if this one is 0, then we write this 0. If this one is 1, then we write the value which is defined in the second line. Okay, that's 0, 2. It's 1, we're just going to write this one, that's 1, 2. If it's 0, we're going to just write 0. 1, we're going to write this value over here. 0, we're going to just write 0. 1, we're going to define this value. 0, 0, 0, we're going to just write all the 0. Okay, that's how we choose. So easy, right? I don't know why they just made it so hard. But the majority is a little bit different. I'm going to just explain it on the same one. I'm just going to explain it here. Let's forget about the third line and just explain it. Okay, actually for majority it's not a big deal. Okay, look, we're going to just check what value has the most. Which binary lines has the most value. Like, for example, in here we have 0, 0, 1. So the most value is 0. The other one is 1, 0, 0. It's 0, 1, 1, 1. Okay, that's all 1. Zeros and 1, 0, 1. Okay, 1 is more than 0. It's just 2, 1, and 1, 0. So it's just like this. We're going to just pick up the majority and write it over here. That's a big deal. So we're gonna just write all of them, like write the value of the final choose, we write over here, just gonna write it over here, and the final value of the majority over here, we just write the sigma value. Okay, as a result, this is going to be a 32-bit value. Then just write it over here. Then, as well as the K and W constants that we already defined. Okay, K is, for example, is this one. I don't know, maybe it's this one, and maybe the omega, we are just picking the omega 0. Okay, it's this one. There's just some values for these ones, not a big deal. Then we're gonna sum all of them. Alright, let's just define this formula. This formula, we have to define it in the Python. And as long as you know what is this code, I'm just gonna copy and paste the code, because you already know it's exactly the same one, not a big deal. I'm just okay, it's ranged 64. It says write rotation to 6, write 11 and 25. As we said, write rotation to 2, write rotation to 3 and 22. Not a big deal. And for choose, we are just picking the biggest value. And for it is temporary 1, and temporary 2. And this is exactly the same as we defined. Yeah, the formula is here. This is temporary 1 and temporary 2. This is exactly the formula. And this is the formula, the majority. This is the choose, majority, not a big deal. And yeah, that's it. There are some write rotations for sigma 1, sigma 2, choose, majority, and the formulas. And the values, definitely. These are the initialization. And at the end, we are going to do what? We are going to sum up the new values, the new hash values that we defined. We're going to sum up the hash values that we define here. These are the new hash values. And these H1, H1, H2, H3 are these ones. H1, H0, H1, H2, they're the old values. We just sum it with the new values to make the new the initialization to complete the loop. So these are the values. I just didn't write it. No, I didn't print it. Okay. Then at the end, I'm going to merge all of them, like join all of them. Here, yeah. Then just type it, make it easier to understand. At the end of the line, I'm gonna do like final SHA-256 hash. I'm gonna just write it SHA-256 hash equals to the joint of the hashes of value, which is 8-bit but hexadecimal. So I'm going to write value 0, 8, but x, not binary. It's hexadecimal. For value in h, this one, h1, right? The new value. That's it, guys. Then print the SHA-256 hash, which equals to the hash function. Okay, let's just make it easier. SHA hash and done. Boomer. Done. That's it. That's the SHA-256 hash value. And also, if you want to be sure that you did it right, by the way, am I recording? Yeah. You want to be sure that you did it right, you can do something else as well. There is this function, I just commented it in here. You can just import the hash library. It's already defined, so you just write the message and write the hash lib SHA-256. You just do the encoding. So let's just see this hello world has this message as well. Yeah, the same message. v29. Yeah, we did perfect. Okay, now let's just remove it. It's just for checking, not part of the code. So this is the output of the system that, okay, I cannot just, I have to take a screenshot. This is the output of the system over here. Okay, this is the value. So we just gave it 512 bits input, put it in the system, and here we go. That's it, guys. Thank you for watching my video. I also put these codes in the description, in the link description, and I'm gonna put this flowchart in the description as well. Also, I'm gonna put my LinkedIn link in the description as well. Don't mind to follow me, and if you have any question, ask me in LinkedIn. Actually, I don't know how is it possible to ask in YouTube. Oh, you can just ask in comment section. And don't mind to like and subscribe, and that's it. Good luck, guys.